Hello, welcome back to BLENDERSUSHI live noding. So this episode is gonna be like the extension from the previous live noding where we are drawing this like a star kind of algorithm. This example came from Sverchok developer Zeffii, and he gave this node setup that's kind of recreating the similar setup like what I did in the previous live noding, but it's much more kind of mathematically correct, I guess. There's like a formula here. So let me try to explain this with my own word. So basically we start with a circle, right? Circle, and it has radius and it has a number of vertices, maybe let's say 8 or 12, whatever, and it's 360 degree. We're not gonna change that. From that circle we know that we need to connect the point. We start from 0. Okay, 0, we're gonna connect it to, for example, to 5, skipping 1 2 3 4, skipping 4, so 0 5 5 10. Let me update this thing first. Let's see how this guy actually connects. Okay, this is one example, and I'm gonna check it out. Okay, 0. This is the indices, the edge indices, how the edge connect together, connecting the vertices. So this is the vertices number, the index number of the point of the circle, and then we have this example, the indices 0 connected to 7, 1 0 1 2 3 4 5 6 7. So 0 7 7 2 2 9, and so on and so on. So this is a complete pattern. One example, I think if you are thinking to design this kind of node tree, that's a kind of like a perfect solution for this. You're gonna kind of going backward. You look at these indices, you write it down, and then you look at it. Okay, the pattern that we need is like, look at this: 0 7 2 9 4 11 6 1 8 3 10 5. There is no repeating numbers. If you can see, that's a kind of mathematical magic, I guess. Same thing with this: 7 2 9 4 11 6. There is no repeating indices number, so which means the whole star algorithm will never kind of overlap with a single like lines connecting everything. This will never repeat itself in the index. But anyway, we have in order to make these indices in Sverchok, we gonna create a list. We can separate this. Just imagine this is the x and the y of the edge indices. So 0 connected to 7, point index 0 connected to point index 7, and then point index 7 connected to 2, and each one of these creating an edges. Okay, so we basically need to create this pattern 0 7 2 9 blah blah blah, and then this pattern, and then we pair them together using this formula. So I will show you what we have at the moment. So we have this pattern 0 7 2 9 4 0 7 2 9 4, and we also have this pattern for the other side. So that's the pair, and we pair them together using a formula node, and then I wrap it using list join, and that's gonna be the final result for this guy. And once we have this set up, we can change the number of the circle points, make it more or less, and then and then you can just play around with this number. and you get a different line pattern. So like I said, there is a math behind this. In the previous live noding, I wasn't looking into math. It's more like I was looking at the list repeat pattern and then how I can connect it using list item. But in this case, it's a math solution for this problem. The nice thing about this is whatever parameter you change, you can see the result right away. Sometimes you want to reduce this or see it like this. This is actually the step-by-step how the math, the algorithm kind of working. This guy will never repeat. For all these points, it's kind of going through all the points but doesn't repeat, and then it creates this nice looking structure. The math itself, I kind of understand it. Like the modulo will kind of loop around. Let me try reducing this. Okay, let's say we have 12 circle points, 12, and then here this is the skipping value. We want to skip every 4, for example, every 5, skip every 5. So let's see the result here. 0, 5, 5, 10. 0, 5, 5, 10. It's actually skipping every 4 here. Actually 5 is the maximum value for the modulo, I believe. Okay, 0, 5, 5, 10. It's skipping every 1, 1, 2, 3, 4, every 4, 5, 9, 10. So yeah, this one is skipping every 4, and this is the value that's kind of determined that. And we need 12 steps in order to generate all this star from the beginning 0 until it goes back to 0. So that's the total number of edges. This is the modulo and range integer and the step. Okay, the step determine how many steps it's skipping, how many index it's skipping. And then we have this add. Let's check this number pattern first. 0, 5, 10, 15, 20. Okay, we get that. And we have another one, 5. This one adding to that. So this is gonna be the points that this is gonna be the next point. In a way, this is probably just like a shifted list of this guy. You see this one 0, 5, 10, 3, 8, 1, 6, blah blah blah, and this one is kind of shifted slightly. So we can actually simply get this result by shifting the list. I'm pretty sure we can do that. So this one we don't need 2 modulo. If I'm doing it a Sverchok kind of way, so I'm kind of making modification here. Gotta and then shift it by -1. So we have 5, 10, 3, 5, 10, 3. Oh, we actually need to shift it over here. So let's check the result here. 0, 5, 10, 3, 8, 1. 0, 5, 10, 3, 8, 1. 5, 10, 3, 8, 1. 5, 10, 3, 8, 1. Okay, yeah, it's slightly shifted, and then so it comes back to itself. So this is another way we can do that. The list length. I would actually just use this guy instead of using this list length and modulo. The modulo, whenever you see the modulo in math, it's basically the number is gonna kind of loop itself. And because we are using this range and integer and then stepping, it's kind of, this node is kind of already doing what we need to do, skipping number and stuff. So to simplify this, even though this is kind of working already, I'm gonna save this. We can simply use list shift. It's gonna give the same result. But anyway, yeah, once it's working, like I said, you can change the number and then play around with this and this to get a result. This is, for me, this looks like a bicycle kind of wheel. If you ever want to do this, you can use Sverchok just to generate this this kind of structure pattern. It ensures that they never repeat, and it's also cover each one of every holes. I guess the same principle, but yeah, I think math itself is fascinating. It's not always easy to understand. It's actually nicer to be visualized. If I'm like a math teacher, this should be probably can be used to explain what's going on. Yeah, I'm gonna save this. Anyway, I'm gonna give this node setup for you. So this is a star shape formula. I'm gonna save this screenshot. Anyway, that's pretty much it for this live noding. Hopefully this is kind of more useful. It's a number pattern, and then there's this indices for the age, and then that kind of basic concept, but important. If you designing something that's parametric, that requires some kind of math formula, you can turn it into nodes, and then once you get that kind of node setup working, you can play with the parameter and get some surprises, surprising result like this. Thanks again, Zeffii, for the example. If you have any question, just let me know, and then I'll see you in the next video.